Welcome. In this lecture, I just want to kind of state the fact that congruence mod m actually gives you an equivalence relation on the integers. So here we go. So proposition. Oh, and this is mod m is an equivalence relation. Kind of gave a name to this. Congruence mod m is an equivalence relation. Okay. Okay, so suppose that we have that, right, we have that m is in integers, or natural numbers, sorry, that m, and here I mean c greater than 0. Okay, then the relation defined by, and so the relation is going to say that A is related to B if and only if A is congruent to B mod m Okay, so this relation is an equivalence relation on the integers. So this relation is an equivalence relation on Z. Okay, so what does this mean? So we have we're going to have, right, so first we have reflexivity. I'll just, what are the properties? So let's do this blue. So reflexivity. The relation is going to satisfy reflexivity. So what is that going to tell me? That's going to tell me that A is going to be congruent to itself. So, right, this is mod m, right? And this is going to hold for all A in the integers. So every integer is congruent to itself. That's kind of what reflexivity here is going to say. And then we have symmetry. Right. And this one is the one where if I know that A is congruent to B mod m, then I know that B is congruent. So this is like an if-then statement. So then I have that B is congruent to A mod m. Right, and this is going to hold for all, now we have, this is for all A and B in the integers. Okay, and then finally our last one that has to be satisfied, and that we can use it, it's satisfied, is transitivity. Right. Which is going to tell me that if, so this is another one of these if-then statements. So maybe I'll write it kind of like this, which is that if, because there's two parts to it. So if I have that A is congruent to B mod m, and I have that, and this is one of these circumstances where I'm going to use the yellow even though I know it looks like green, just so that I know I'm using a different color. They're slightly different. So this is not the same color as that. So B is congruent to C mod m. So if both of these hold, then we can say that A has to be congruent to C, right? So then I have that A is going to be congruent to C mod M. And then we have for all, right, so this works for all A, B, and C in the integers. Is that the yellow or is that the green? Who knows? Okay, in the integers. I don't know, I'm still making them like this. Okay. So, right, so to prove this, one needs to show, right, each of these statements that this relation is going to satisfy reflexivity, symmetry, and transitivity. And then once you know that, right, this is true, that this is an equivalence relation, you can use these properties. So that's going to be really useful. These are these properties that you can translate into M divides B minus A, and then that gives you a Q such that A times M equals, Q times M equals B minus A, and so on. So you have all these things to work with there. But this is actually a very kind of cool statement. It gives us a lot, actually. It allows us to look at everything in the same equivalence class as being kind of in some sense the same element. Okay, so I hope that made some sense and was useful and helpful, and I will see you in the next lecture.